Hi everyone, this is my second video for Math OED2 2.1, which is solving systems of equations by graphing. So I'm only making a couple of these videos because if you know how to graph one line, then you know how to graph two lines. And then once you graph two lines, it's pretty easy to tell visually whether they are parallel and never intersect, whether they intersect once, or whether actually they're the same line and intersect an infinite number of times, again, because they're the same. So if you are really struggling with graphing, go back and watch some of my Chapter 1 videos on how to graph lines, and that will kind of supplement this section if this is difficult for you. So the first thing we need to remind ourselves of are the three different ways that we've learned so far to graph lines. Okay, so one method that we have at our disposal is to get an equation in y equals mx plus b form, which we could do with both of these equations if we wanted to, okay? And then from here, we would graph the y-intercept, and then we would use the slope to generate additional points, okay? So this will be, we'll call this method number 1, okay? Another method that we learned back in Chapter 1 is to find the x and y intercepts and to graph those. Okay, generally speaking, we tend to do that when I have something that's in the form ax plus by is equal to c. Okay, and then the third method is to just choose or assign random values of x, and then to solve for y. Okay, and if you think about it, finding the x and y intercepts is kind of a subset of that to some extent. Of course, when you find the x-intercept, you're substituting 0 for y instead of for x. But they're very similar, okay? So, again, you can choose any of these three methods. So even if, for example, 2x plus y equals 4 is not given in y equals mx plus b form, okay? If I wanted to, I could rewrite it in y equals mx plus b form. Okay, now I'm not saying that that's what you have to do. I'm not saying that's the only way to do it or even the best way to do it. This is just one way that you could approach this problem and graph this line. Okay, so when we do that, remember we have to isolate our y. So we would have y equals negative 2x plus 4. Okay. From here, we have our y-intercept, which is 4, so that would be right here. It doesn't like it when I try to go over a point. There we go, okay? And then from here, I need to use the slope of negative 2. So the slope of negative 2 means I go down 2, okay? And then, right, because negative 2 is the same as negative 2 over positive 1, or negative 2 over 1, then I would have to go right 1 unit, okay? And I can keep doing that. Go down 2 over 1, down 2 over 1, okay, until I run out of graph paper, okay? Now, what if I want to generate points on the other side of my y-intercept? Well, I can totally do that, right? Except for instead of going down, this time I'm going to go up 2, and then I go left 1. Okay, so remember, if it's negative, then you need one negative and one positive. Do you see how I have one red line and one green line, right? Down is negative, right is positive. Up is positive, left is negative. So if I continue in this direction, then I have the rest of my points, and then I can connect them in the line. And I mentioned in my other video, in these problems, you're generally always going to have two lines on a graph. So it's a good idea to get into the habit of labeling those lines so that you can keep them straight, okay? At some point that will come in handy. All right, so let's look at the second equation that we have. We have 3x plus 6y equals negative 12. Okay, this is the equation that I'm looking at now. So I could, if I wanted to, solve for y. But as you can see, that's going to take two steps. First, I would have to subtract 3x from both sides, and then I'd have to go through the trouble of dividing everything by 6. Again, you can totally do that. If that's your preferred method of graphing, then that's what you should do. Stick to what works for you, okay? What I'm going to do, just to give you a sampling or a smattering of different methods so that you can make an educated and informed decision about which one is your favorite method, okay, I am going to pick this one right here where I find the x and the y intercepts. So in my last video, I demonstrated this one, and we just did this one again, and I also demonstrated the third method. So this time I'm going to do that one, this method right here, the x and y intercepts, and then hopefully that means, well, I will have covered all three methods in between the two videos. Okay. So to find the x-intercept, you may recall, we have to set y equal to 0, and to find the y-intercept, we must set x equal to 0. So let's go ahead and work through this. Okay, so I'm going to have 3x plus 6 times 0 equals negative 12, right? Because that's the whole point, is that we set y equal to 0. So then we have 3x equals negative 12, divide by 3. We find out that x is equal to negative 4. Okay, so this is generating the point negative 4, comma 0. That is our x-intercept. And we can go ahead and plot that on the graph. I'll color it in orange because orange and purple go so well together. Okay, there it is right there. That is the point. Negative 4, 0. Okay, so let's go back and find our y-intercepts. Recall, to find your y-intercept, you set x equal to 0. Okay, so we get 6y is equal to negative 12, divide by 6. We find out that y is negative 2. So that actually gives us the ordered pair 0, negative 2. So where is that? That is right here. Okay, so if I connect these two, I can use, I can draw a line here if I wanted to. I could just go ahead and draw one. Okay, but let's not get carried away. Let's look a little bit closer at this and see if we can continue this trend. So if I look at this sort of triangle here, right, you can see that we went down 2 and over 4. I want to generate more points. So what I'm going to do is I'm going to keep that trend going. I'm going to keep going down 2 and over 4, down 2 and over 4, down 2, and we're off of the graph, so we can finish. Okay. And then, right, if I wanted the other points on the other side of our x-intercept here, I could go instead up 2 and over 4, up 2, and we're out of a graph. Okay. So those are my other points. All right, so now I have lots of points to work from. I like to have lots of them that cover the graph, so you don't have like this sort of drift effect. Okay, so that's annoying. Whatever. We'll go with that. It gets a little bit off up here. Sorry about that. Okay, but the main goal here isn't to, create some sort of like brilliant Picasso, right? The point is just to find out where do these lines intersect. So hopefully I did a good enough job with this process that you can see that the lines meet right here. Okay, so I'm going to erase some of this writing so that you can see the numbers on the graph. Okay, so hopefully you can see that on this graph x is equal to 4, and that is really unfortunate. This highlighter is so weird. And then y is equal to negative 4. Okay, so this point right here is the solution to your system of equations, and it's x equals 4, y equals negative 4. So hopefully that helps you. And again, remember, you have all three methods that you can use. Those are all tools in your toolbox, okay? You choose the tool that is best fit for the job that's being given to you.